Hello students, in this video lecture I am going to discuss about the HOTS questions of the physics of class 10. First question is that 3 bulbs rated as 60 watt to 20 volt, 100 watt to 20 volt and 40 watt to 20 volt are connected in the series. What will be the equivalent power of the combination? So in series grouping, the formula we use 1 by P is equal to 1 by P1 plus 1 by P2 plus 1 by P3, or using this formula we will calculate the equivalent power of the combination in the series grouping. So question is that the 3 bulbs, that is a 60 watt to 20 volt, 100 watt to 20 volt and 40 watt to 20 volt are connected in the series. The equivalent power we have to calculate. So question is that the 3 bulbs rated as 60 watt to 20 volt, 100 watt to 20 volt and 40 watt to 20 volt. 60 watt to 20 volt, 100 watt to 20 volt and 40 watt to 20 volt are connected in series. Find equivalent resistance power. Find equivalent power of the combination. Equivalent power of the combination we have to calculate. So equivalent power of the combination we have to calculate here. Now answer is that answer of this question is that in series combination, 1 by P equal to 1 by P1 plus 1 by P2 plus 1 by P3. Now here P1 is given 60, P2 is given 100 or P3 is given 40. Now its LCM will be 600. Now that is a 10 plus 6 plus 15. Now that is equal to 31 by 600, 1 by P. Therefore P will be equal to 600 by 31 watt. So here equivalent power will be equal to 600 by 31 watt, or if we divide then it will be equal to 631, that is equal to that is equal to 19.3. So if we solve this, it will be equal to 19.3 watt. So that will be the equivalent power of the given question. Now second question is that now we will discuss about the second question. What is the second question here? Now second question is that a circuit has a fuse of a circuit has a fuse of 5 ampere. A circuit has a P of 5. What is the maximum number? What is the maximum number? Is the maximum number of bulbs 100 watt to 20 volt can be safely used in the circuit. Now question is that a circuit has 5 ampere fuse, and question how many 100 watt bulb can be used in the circuit that have 5 ampere fuse. So first of all we will calculate the electric energy consumed by the single bulb, or total current is given here the 5 ampere. So now we will calculate the current is required to operate a single bulb. So now current consumed by single bulb, here answer is that electric current consumed by a single bulb. So power is given, P is equal to VI. We know using the formula P is equal to VI, I is equal to P by V. Power is given 100 watt, or that is equal to 220. So we can solve 5 by 11 ampere. 5 by 11 ampere current is used by a single bulb, or total current rating of the circuit is a 5 ampere. So now number of bulb will be equal to, now here is given current rating of the circuit, current rating of the fuse, that is equal to 5 ampere. Therefore number of bulbs, can be used safely, that is equal to 5 by 11, that is equal to 5 into 11 by 5 to 5 cancel, that is 11. So the 11 bulbs of power 100 watt and 220 volt can be operated safely. Now question number 3. Question number 3 is given. The frequency of AC current, the frequency of AC current, in India is 50 Hertz. What does it mean? What does it mean? Answer. The frequency is 50 Hertz. It means that the direction of AC changes 100 times in 1 second. The direction of AC changes 100 times in 1 second. So it means that the direction of AC, it means that the direction of AC changes 100 times, it means that the direction of AC changes 100 times in 1 second. 100 times in 1 second. Now next question we will discuss it. Question number 4. I am going to discuss about the question number 4. Question is that a circuit the question is that what is the capacity? Question is that what is the capacity of a fuse? What is the capacity of a fuse commonly used in domestic electrical fittings. So we are using electric fuse in domestic circuit. They are generally of two types. One 5 ampere fuse and other is the 15 ampere fuse. 5 ampere fuse is used in the circuit where the less power is consumed, and the 15 ampere fuse are used in the circuit where large power is consumed. So generally 5 ampere and 15 ampere fuse are used in the domestic circuit. So answer is the 5 ampere and the 15 ampere fuse we are using in the domestic fittings. So answer is that 5 ampere and 15 ampere fuse. So your answer is that 5 ampere and 15 ampere fuse are used in domestic circuit. In domestic electrical fittings. So 5 ampere and 15 ampere fuse are used in domestic electrical fittings. Now next 5th number questions. We will discuss about question number 5. Now question 5 is here. Question 5 is that, so under what condition? Question is given that under what condition does a moving charge experience a maximum and minimum force in the magnetic field. The question is that under what condition does a moving charge experience a maximum and minimum force in the magnetic field? So when a charged particles enters into a magnetic field with a speed v having charge q at an angle theta, then it experiences force q vb sin theta. If theta is equal to 90 degree, then sin 90 is equal to 1. So q vb is equal to 90 degree. Q vb, that is the maximum force. So when charged particle enters normally to the magnetic field, then it experiences maximum force. And if theta is equal to 0, it means that charged particle moving parallel or anti-parallel to the direction of the magnetic field. So in this case, the particle will not experience any force, and that will be the minimum force. So first case, when charged particle enters normally to the magnetic field, so it experiences a maximum force and follow the circular path. So here we will discuss the answer. Suppose that this is a field, this is a magnetic field directed towards the surface, and when charged particle enters normally to the magnetic field, charged particle enters normally to the magnetic field, then it experiences maximum force and it follows the circular paths. It follows the circular paths here like this. So here charged particles is moving on a circular path. Its centripetal force will act towards the center and follow the circular path here, and the direction of the motion of the particle will be along the tangent of the circular path. So first case here, force will be experienced by Q VB sin theta. If theta is equal to 90 degree, sin 90 is equal to 1. Therefore, F is equal to QVB, and this is the maximum force. This is the maximum force. This is the maximum force. So, when particle enters normally to the magnetic field, then it experiences maximum force. So, when particle enters normally into a magnetic field, then enters normally into a magnetic field, then it experiences zero force. Magnetic field, then it experiences zero force. Or if theta is equal to 0 degree or 180 degree, sin 0 is equal to 0, sin 180 is equal to 0, therefore force will also be equal to the 0. So if particle moves parallel or anti-parallel to the direction of the magnetic field, then it experiences the first case, that was the maximum force. So then it experiences maximum force. First case is maximum force. Or if theta is equal to 0 or 90 degree, then force will be 0. So if particle moves parallel or anti-parallel to the direction of magnetic field, so particle moves parallel or anti-parallel to the direction of magnetic field, then it experiences zero force. Now, next question is that name the scientist that find the relationship between the electricity and magnetism. So, Oersted set up the relation between the electricity and magnetism And according to Oersted observations, a current carrying conductor behaves like a magnet and magnetic field is produced around it, and the direction of magnetic field changes due to change in the direction in the current in the circuit. So Oersted set up the relation between electricity and magnetism. So next question is that here, name the scientist. Question is that name the scientist. Name the scientist who discovered. Name the scientist who discovered the relationship between electric current and magnetic field. Between electric current and magnetic field. Electric current and magnetic field. Scientist is H.C. Oersted, Hans Christian Oersted, a Danish physicist, set up the relation between electricity and magnetism in 1820. So, name is the H.C. Oersted, Hans Christian Oersted. Answer is H.C. Oersted. Hans Christian Oersted set up the relationship between electricity and magnetism. Now question is that, next question we will discuss here. Question is that, how can the magnitude of induced current, how can the magnitude of induced current, how can the magnitude of induced current in a coil be increased? So now question answer is that, first answer, the induced current in a coil can be increased by increasing the number of turns in the coil. So first is by increasing the number of turns in the coil. Second, by increasing the strength of the magnetic field. Third, by increasing the speed of the magnet, with which by increasing the speed by increasing the rate of change of the magnetic flux linked with the coils. So the rate of change of the magnetic flux linked to the coil induces the induced EMF, and that set up the induced current in the coil. So first factor is by increasing the number of turns. Second, by increasing the strength of the magnetic field. And third, by increasing the rate of change of the magnetic flux linked to the coils. So these are the basic questions of the electric current, or in next video we will discuss more questions. Thank you.